Hello again, this is Mr. Steele. Today we're going to be looking at standard number 6 on the term 3 and 4 Algebra 2 standard quiz that asks you to factor polynomials. And of course, you know what a polynomial is and you know what factoring is for the most part. And this is factoring, just like you've done before. The difference is that the polynomials we face aren't going to be so nice. They're not just going to be simple little easy diamonds where the degree is 2 and you just do one little diamond, that's it. Notice, just looking at this first example that I've thrown up here, even before we even talk about the ideas, is that this is degree 4. So we're going to have to adjust our factoring strategies as well as kind of recognize which type to use in which situation, while always keeping in mind the easy diamond and difference of squares kinds of strategies we used before. So first I'm going to begin with this one. This is a degree 4 polynomial, so if we were solving we'd know how many solutions we want, but here we don't want to. All the instructions ask us to do is factor. We just want to break this up into a series of factors. So our answer should ideally look like something like this. It'd be a whole bunch of parentheses with little binomials inside it, or maybe trinomials, just depends on the problem. So first looking at this guy, this thing goes by different names, but really this is just kind of like the diamond. It's very similar to the normal diamond kind of strategy. It's just kind of quadratic. So one of the names that we kind of give this guy is that it's quadratic-ish. Because it's clearly not quadratic. Quadratic you have to be degree 2, and this is clearly not degree 2. This is degree 4 in fact, which is definitely not quadratic, despite the fact that quad means 4. So in fact, the first thing we have to do is we kind of got to know what to do with the quadratic-ish type. And for the quadratic-ish type, we're basically going to start with a simple strategy. We're going to diamond it, just like we would normally. In this case, it's going to be a hard diamond. And then we're going to just start breaking it up. We'll do the same way we did with the diamond. The difference is we'll have stuff with x squared in here, because what we normally do is we break up this middle term. And so I'll show that step. I'll show the box step, or the factoring step, whichever way you want to call it. And so first, to do this, let's go ahead and just begin the diamond. We're just going to pretend that this is a quadratic and it's a normal diamond problem. So for this guy, we got a number in front. We have to figure out what two numbers multiply to 4 times negative 9. Well, 4 times negative 9 is negative 36, and add up to negative 5. So that's what we need. We need those two numbers. Well, thinking about it, especially with those 4 and 9 sitting there, it's pretty quick to see, I think, that the two numbers that work are going to be 4 and 9. And this one, the 4 is going to have to be positive, and the 9 is going to have to be negative in order to add up to a negative 5. So the way we can kind of start is we can start by finding those two numbers. Now what that allows us to do is it allows us to break it up. We can either do this and split the middle this way. This is one strategy. So what I'm doing is I'm transforming that minus 5x squared into a sum of plus 4x squared and minus 9x squared. And then I'll factor from here. Or if you're a box person, which is totally fine. Okay, that's a crappy box though. I'm going to draw it a little lower. So if you're a box person, we'll do the same thing. We'll just put those terms inside the box. We'll have 4x to the 4th. Let's go minus 9x squared plus 4x squared, and then minus 9. And so either way, we're going to end up factoring it. If we split the middle, we'll be factoring it this way, pulling out GCFs. If we use the box, we'll be pulling out sideways, and up and down. So I'll start with the box. I'll use the box. I like the box. So the GCF here from the box is going to be 4x squared. Over here, excuse me, it's going to be negative 9. On this side of my GCF, it's just going to be x squared. Only the x terms have any factor in common on that top row. And then down here, all I've got is a plus 1. And now these guys that we've gotten and acquired by GCF factoring with the x to the 4th x squared and everything like we would in normal quadratic are going to be our factors. It's going to end up 4x squared minus 9 and x squared plus 1. Now at this point we would be done, except for the possibility that arises because of that squared. We could actually have difference of squares sitting here. In this case, in this first one, we have a really nice, neat difference of squares. 4x squared minus 9, if we think about it, they have neat little square roots. So this is going to actually break up into 2x plus 3, since the square root of 4x squared is 2x, and the square root of 9 is 3, and 2x minus 3. So the answer we'll be looking for on the standard would be this guy, because x squared plus 1 is not a difference of squares. We want a difference of squares. So there would be our answer. Now at the same time, you could go further if you wanted to. Some of you in my classes have gotten comfortable doing this, and you could see this as a difference of squares. You could see it as x squared plus 1 equals x squared minus negative 1, And of course, -1 is the same thing as I squared. So you could see this as x squared minus I squared. In which case your final answer would be the same 2x plus 3, 2x minus 3, times x plus I, x minus I, where I is the complex number, or the imaginary number, the square root of -1. So that would also be an acceptable answer. And in fact, this one is probably the best answer, but I'm not expecting you to go that far. For the classes that I have this next term, most of the time if you're in regular year-long, this is what we're really looking for, especially with this one. But again, basically all we did was we just kind of followed this one strategy. Our strategy, or our plan, was pretend it was a diamond. And that strategy actually worked out. We were able to get it down to an answer which is totally broken up. So what was 4x to the 4th minus 5x squared minus 9 actually breaks up into 2x plus 3, 2x minus 3, x squared plus 1, or if you want to break that up further, x plus I, x minus I. So there weren't really any key facts here except for what we already knew about factoring diamonds. And so there's one strategy. This is one type of factoring problem that could come up for standard number 6. Well, let's take a look at another type. Okay, so here's our second factoring type, and this one we're going to actually see not a trinomial, but a 4 terms, so a 4-term polynomial. So when we look at it, it might not immediately jump out to you what to do, because it's tempting to think, oh, well, I always got to use the diamond somehow, or there's got to be something fancy. But in fact, this one actually screams out kind of the step after the diamond. Like, you should be thinking about grouping it together. Like, we will, as one strategy, just like completely split the middle here, and then factor out GCFs, or we can go straight to the box. So our tools here are going to be those two things. Split the middle, if that's your strategy. It's already kind of split, so in a sense, like, it's almost kind of in quotes. Or we can use the box. They'll both accomplish the exact same thing. And of course, this type is called factoring by grouping. Factor by grouping. And what's nice about it is it allows us to just take advantage of the fact that we've already got pairs ready to go. So I'll start with the box, because that's the way most people in my classes do it. So starting with the box, since we have 4 terms, we just put 1 in each one. And we do have to make sure we put them in order. It doesn't really matter which order, well, it does matter which order. So we start this way. We've got the first 2 terms in there. And so now I've just got to look for GCFs, like what GCF comes out of each row and each column going up and to the left. So over here, my GCF is going to be -25. My GCF will be 4x squared. And so you might already be thinking, oh, I've got a difference of squares there. We do. Going up here, we get an x. And then up here, my GCF is just going to be 2, I think. And let's see, check it real quick. Positive 2, -25 adds and multiplies to -50. Yep, we're good. So it appears that our factored polynomial turns out to be the product of 4x squared minus 25 and x plus 2. And of course, this is, just like the last time, this is our final answer. The only problem that comes up, or the only possible catch, could be if this thing factors. And as we see here, this guy does factor as a difference of squares. Of course, it can't be a square unless you have the right angles there. So in fact, what we have to do here is we have to do the same thing as we did on the last problem. We need to go through and deal with the difference of squares as well. So we'll end up with 3 factors in this case. Looking at this guy, looking at this problem, 4x squared minus 25, if we think about their square roots in our mind, square root of 4x squared is once again 2x, so our first factor is going to be 2x plus the square root of 25, which is 5, so 2x plus 5. The other one will just be the same factor with a minus instead. And then lastly, x plus 2. Now we're not asked to solve, we're just asked to factor this guy. So in fact, our final answer is right there. 2x plus 5, 2x minus 5, and x plus 2. This is probably, if we're looking realistically here, as far as like least computationally demanding, this is probably the best problem to get. Like, this is the one you want. Like, it's very straightforward to break up. You always just have to be on the lookout for difference of squares so you don't accidentally miss something that you've correctly factored in the beginning. So we've hit 2 of the 3 possible factoring strategies that you'll see. We've hit ones that are quadratic-ish, and we've hit ones that require you to group. We'll go on to the last one, the most interesting of all of them, I would say. Okay, so here it is, the final factoring strategy you'll have to hit. And this one is distinguishable from the other ones because there's only two terms. So previously up to this point, the only factoring we've done with two terms here has either been GCF or it's been difference of squares. But of course we can't have a difference of squares if we don't have a square up there. We actually have a cubed, so it's kind of different. Like, it's not actually going to be the same thing. So instead, what we need to do is we kind of need to learn a new strategy, or at least kind of refresh on a new strategy since you've seen this before. That strategy is, at least at Franklin, called MOP. And the MOP strategy relies on two things. It relies on you recognizing that there's a difference of cubes that's hiding in there, and it also relies on you getting comfortable using that actual factoring strategy. So let's actually work with a couple different pieces here. So first, the MOP thing, I like to start with by thinking about not what MOP means, but what it actually looks like. When you factor it, you don't get three factors out of it, you actually just get two. A short factor, which comes out really quickly and is usually pretty easy to see, and a long factor that's quadratic, like one that has its own little trinomial. Now it's a quadratic one, but it's never factorable, so it's NF every time, so keep that in mind. And then from here, to fill in the pieces, what MOP stands for are how the signs are going to align inside the individual factors. The first sign we come across, as in SIGN, as in plus or minus sign, is going to be matching the original sign. The second one's going to be opposite of the original sign from the original problem. And the last one is always just going to be positive. And again, this is always going to be in reference to, let's do this, matching opposite or positive the original sign. So whatever it was in the problem originally, plus or minus, we're going to copy that. I don't know why I switched to lowercase, whatever. So looking at this problem, you might be going, well, there's so much going on here. Like, there's already something weird here. We got 56x cubed and 7 here. Well, the first thing we have to do is, just like any kinds of factoring, not that we've seen it yet today, is we do have to pull out any GCF. So in this case, our GCF is 7. So we're going to want to write that 7 out in front. And that will leave us with 7 times 8x cubed minus 1. So this guy is just going to hang out. He's going to be out there no matter what. That GCF doesn't go anywhere here because we're actually just factoring. We want to see all the factors that would go into making this guy. But this guy in here is what's going to mop. We're going to mop with this thing. We're going to first start by figuring out what's being cubed. So if this is going to be mop, that means it's a sum or a difference of cubes. Should probably write that. Sum or difference of cubes. And so if we want to use a sum or difference of cubes, just like we did in the difference of squares where we took the square root, we got to figure out, well, what's the cube root here? What is it that's being cubed in each case? So I always like to think about it as just trying to answer that question. What do we cube to get there? Well, what you cube to get 1 is just 1. So that's pretty clear. And then what you cube to get 8x cubed is, well, obviously you need an x for the x cubed. And for 8, that's 2 cubed. So our ingredients here are going to be 2x and 1. That's what's going to go into our MOP. So next we can actually start. We'll put our GCF down, which I probably should have included over here, and just written GCF times all that. And now we're going to need a short factor and a long factor to include all these pieces. So first we start with the simple one. Let's just put in the individual ingredients. The first things that will go into the short factor are going to be the individual pieces themselves, 2x and 1. And so there they go. We'll not worry about the sign just yet. The next thing, in the next factor, we're going to need to include their squares. So we're going to have 2x, it's going to be squared, and we're going to have 1 being squared. Like, the reason we do that is that way when we multiply this out, we'll end up with what we want. If we square this, we'll get 4x squared times 2x is 8x cubed, and 1 times 1 is going to be 1. Now the last piece in the middle is just going to be the product of those two. So here we've got 2x times 1, or 2x and 1, so we're going to put 2x times 1, whatever that comes out to be. In this case, it's pretty simple. It's trivial. It's 2x. But in other problems, we might actually have to think. And so there we go. We've got each of the individual pieces here now. We can simplify them, but before we do that, let's add the signs. So MOP tells us the signs themselves. So looking at our original problem, our original was a minus. So off to the side or in your head, you might want to keep in mind that the original sign was a minus sign. And so now we can go over to our MOP, or to our factors, and start filling them in. So the original sign was a minus. We're first going to match the original sign. So match the negative, that's a negative sign. The next one's going to be the opposite of whatever we just had. So the opposite of minus is plus. Finally, the last one's positive no matter what, so doesn't matter, we'll get a plus sign in there. And this guy will be our final answer, our product of factors that give us 56x cubed minus 7, so long as we actually go through and simplify everything. So 7, 2x minus 1, those are all fine. The next factor, 2x squared, it's not just 2 times x squared, it's 2 squared, x squared, plus 2x times 1 is just 2x, plus 1. And there is our answer. 7 times 2x minus 1 times 4x squared plus 2x plus 1. And this guy never factors, it never does. When we solve with it in standard number 7, we'll always get plus or minus I root 3 as an answer, which tells you that of course it doesn't factor. Like, you don't get out anything nice when you do it this way. And so there we go, there's our mop. Like, we've used mop to kind of identify what the factors are going to look like to avoid that common misconception. We factored out a GCF, and then we used the factoring strategy of mop to come up with this answer. And yes, it is different. I mean, basically, you can either divide to get it every single time, or you can just memorize the exact pieces, short and long, and then where your ingredients go inside it. The pieces themselves, their squares, and then the product in the center. I think it's pretty straightforward. Really quickly before I go, just because I know this one is kind of a frustrating one or a challenging one for some people to get, let's do one more, just a mop one. So let's factor 125x cubed plus 64. Okay, so as our second little problem here, you get a little bonus. In fact, let's write that there. Bonus. So as this last one, we'll do the same kind of process, just to illustrate it again so you see a couple examples. So first, figuring out what stuff's being cubed here, because we see that there's no GCF, 125 and 64, no common factors because it's just 5s. We can go through and figure out what's being cubed. So what are the cube roots? That will give us the ingredients here. Don't know what happened there. Well, for 125, that's just going to be 5 cubed. It's 25 times 5. And then we need the x. And for 64, that's just 4. Most of the time I do these really quickly in my head because I've already figured them out, like you've used them so many times. Next, from here, we know for our mop we need a short factor and we need a long factor. So there they are. Let's make them bigger. Short factor, long factor. And now we can go through and actually put in the pieces. So the first factor is the easy one. We've got 5x and we've got 4. The next one, we need their squares. So I can go ahead and just put like the skeleton in there. So the first one is 5x, so we need its square. And the last one is 4, so we need its square. And then in the middle, we need to multiply the two. 5x times 4. So mult in the middle, square, and square over here. And then the originals on this piece. So that's kind of the hidden part of mop. You have to just recognize where those pieces go. Okay, next, the signs, matching opposite positive. Our original was a plus. So our first one is going to be matching that plus. Our second one's going to be the opposite. And our third one will be positive, because it's always positive anyway. That means that our final answer here, if I may, will be 5x plus 4. 5x squared is going to be 25x squared. Minus 5 times 4 is 20, so minus 20x. Plus 16. And that will be our answer. Voila. Okay, so over the course of this video, you've seen a couple different pieces. You've seen factoring quadratic-ish polynomials, where you really just do the diamond, but remember that that middle term being x squared means you have to be extra careful, and you need to factor across those. The second one we saw was factoring by grouping, which is by far the easiest method, and that's just splitting the middle or using the box to break it up and take GCFs. I'm not forgetting differences of squares here either. Finally, our last one would be the MOF strategy, which is really the sum or difference of cubes, and that asks us to break things up according to this pattern of factors, a short one and a long one, where the short one includes just the original pieces that were being cubed, and the long one includes the squares and then the product of the two original pieces. And you got two examples, one where there's a GCF and we kind of talked through it a little slower, and one where we actually factored the whole thing as a bonus. And so, hopefully with any luck, this video has been a help to you, and that number 6 won't pose as many small little problems as it has in the past. So this is Mr. Steele, signing off. Have a good night. Well, that's a miserable smiley face. Let's put a cosmetic surgery and give him a nice eye. That's a little bigger. There we go. Have a good night.